Okay, pause copy, and try this exercise. La 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 la. Okay, definition here. So for infinite on both sides, we will choose as our definition to break this up. So C can be any real number you want. Often we pick 0. But, you can pick 1 if you want. You can pick 26. Maybe you have a fancy for 57. I don't know. Whatever you like. But often 0 is easy to work with. So that's what we'll do here. And we will say that this equal sign is only used if both pieces converge on their own. Okay, so we break it up. I break it up at 0 here. And a question mark here. So again, because I have this if here, I don't even want to talk about that equal sign unless the two pieces both converge on their own. Okay, both of them require a limit. Excuse me, this is getting messy now. But thankfully, they're both the same antiderivative, which I did substitution, u is equal to negative x squared. So I'll use that in both cases. Maybe I'll just scroll up and let you pause and copy here. Okay. Pause and copy all this. Then I will talk. Okay, what am I doing again? Oh, yes, I used this antiderivative right here and right here. Fundamental theorem of calculus. Okay, still not doing a limit until the very last step. Okay, finally I do the limit. Let's see. Let's look at the first one. Negative. You have negative a squared is becoming negative of negative infinity squared. This is a sticky wicket sometimes. You actually get minus infinity here. You have to be careful with that. Yeah, I notice students have trouble with this expression sometimes. Lost my thought bubble. I'm using these thought clouds because as a good mathematician, you do not plug infinity into your equations. You use limits instead. But the little thought cloud is still helpful for thinking. Now, where was I? Okay, so this becomes 0, this becomes 0, and it comes out pretty simply. So I got 0 here. So that's a real number. So my improper integral is convergent. So I need you to say convergent or divergent, depending on the case. Okay, how can we get 0? Well, here's a little picture here. This is roughly what the function looks like. You have an area up here that's counted as with a plus, and then you have an area down here which is counted with a minus, so they cancel. Okay, I want to do one that's doubly infinite and diverges, just to show you. Okay, very simple. Very simple, oopsie daisy. Very simple integral, but maybe pause and copy before I blather anymore. Excuse me. Okay, so break at 0 again. And then I focus my attention on just one of them because my spider sense is telling me that something is not going to work here. So I do the antiderivative. It's just a negative pops out in front there. FTC gives me this. And then I have E to the infinity, which is obviously infinite. Okay, so this limit is infinite. That's not a real number. So this guy turned out to not be a real number, so it is divergent. So I stop everything right now. I do not even think about the second one, because under my definition, I'll pause and copy this. Under my definition, we require both pieces to converge. So as soon as you realize that one of them diverges, you were done. Okay, pause and copy. Now we're going to do something different. We're going to look at not infinite intervals, but we're going to look at functions that have an asymptote, which appears somewhere in this interval. Excuse me. So if I look at this function, I can't plug in 0, right? But 0 is occurring here. So I hope you would agree this is improper. Something funky going on here. So the picture gives you an idea of what I'm calculating visually. Again, I have an area that appears to be infinitely high, but that doesn't mean that it's an infinite area, because we can calculate in a manner similar to the way we did before. So pause and copy. So what I'm going to do is illustrate it in this picture here. I have a certainly finite area here where I go from A to 1 instead of 0 to 1. So I'm going to find that. I'm going to find that certainly finite area. And then I'm going to allow A to move to the left. So A is going to approach 0, and the plus indicates that it's approaching from the right. From the right. So that's a bit confusing. You remember from Cal 1? A is moving left, so it's approaching 0 from the right. Okay, so again, I focus my attention on this integral. I work it out here. And then I see that when I plug in A equals 0 here, there is no problem. Okay, square root of 0 is 0. So I got a number here. So we say that this improper integral up here is convergent. Okay, so again, you must put your limits. And I am also going to insist you put this plus here. Okay, this plus here is worth half a mark. Okay, that's the end of this video. So pause, copy, and try this exercise.